I'll share a real-life example with you. We know that in the general population, IQ scores follow a normal distribution or a bell-shaped curve. We also know that in the general population, the mean IQ score is 100, and the standard deviation of IQ scores is 15. That means that a person who has an IQ score of 100 has a z-score of 0, since that person is right at the mean. It also means that a person who's 15 below 100 at 85 has a z-score of -1, and a person who's 15 above 100 at 115 has a z-score of +1. So 85 is -1, and 115 is +1. Since IQ scores follow a normal distribution, we know that 68% of the population falls between 85 and 115 because, like I said, when a population is normal, 68% of the population fall between -1 and +1. Also, a person with an IQ of 70 would have a z-score of -2, and a person with an IQ of 130 would have a z-score of +2 because if you start at 100 and go down by 15, that's 85. And if you go down by 15 again, that's 70. And if you start at 100 and go up by 15, that's 115. And if you go up by 15 again, that's 130. So a person with an IQ of 70 is at -2, and a person with an IQ of 130 is at +2. Since IQ scores follow a normal distribution in the population, we know that 95% of the population has an IQ between 70 and 130, because like I said, if the population is normal, then 95% of the population falls between the z-scores of -2 and +2. Now let's think about what IQ scores go along with -3 and +3. Well, if you start at 100 and you go down by 15, that's 85. If you go down by 15 again, that's 70. If you go down by 15 one more time, that's 55. So 55 goes along with -3. If you start at 100 and you go up by 15, that's 115. If you go up by 15 again, it's 130. If you go up by 15 again, it's 145. So -3 is an IQ of 55, and 145 goes along with +3. And I told you just now that if a population is normal, 99.7% of the population falls between -3 and +3. That means that in the general population, 99.7% of people have an IQ between 55 and 145.